There are still 4 other water wall problems we need to talk about: clinker damage, flame or fuel impingement, trouble with burner openings, and trouble with inspection doors. Now, clinker damage occurs when clinkers high in the furnace fall and hit the water wall tubes at the bottom of the furnace. This causes tube bending, crimping, and denting, and it also wears away the tube metal. Severe bending is a serious problem because it'll restrict water flow, which leads to tube overheating and failure. Wearing away of the tube can result in tube failure as well. Be sure to check for all these conditions when you inspect the clinker impact area at the bottom of the boiler. Flame and fuel impingement occur near the burners. Impingement is the throwing of flame and fuel against the water wall rather than into the center of the furnace. Flame impingement can be detected by discoloration or blistering of boiler tubes in the burner area. Fuel impingement is found in the same general area as flame impingement and causes tube erosion. Look for this erosion as well as fuel accumulation to detect fuel impingement. Another case of fuel impingement is faulty burners that throw unburned fuel across the furnace. If you find fuel impingement, you're likely to find flame impingement as well, so be on the lookout for both. If you find fuel or flame impingement, the burners must be examined carefully. Burner parts must be checked for wear due to erosion, damage from heat, and improper alignment. If there's evidence of flame or fuel impingement on the water wall, check your boiler's manufacturer's manual for alignment instructions. Refractory at the burner opening should also get close attention. This refractory is exposed to particularly high temperatures. While checking this refractory, look to see if ash and slag have accumulated on the refractory or in the burner opening. Now, they could prevent proper burner operation by obstructing the burner openings where fuel enters the boiler. Burner openings in the water wall contain air ports that supply combustion air to the furnace. Sometimes air ports are built directly into the burner. These should be inspected to make sure they are clear and are allowing a free flow of gas. Also, make sure they're not deformed. Deformed air ports alter the correct pattern of air flow. When looking at inspection doors from inside the boiler, watch for 2 things: blockage from ash or slag accumulation and deterioration of the refractory in the inspection door openings. While checking the water wall, inspect the radiant superheater if your boiler has one. A radiant superheater is built into the furnace wall just above the water wall. Since the radiant superheater is located in the same area as the water wall, you should inspect both at the same time. Radiant superheaters can have the same problem as any other boiler component. These include overheating, support failure, excessive ash accumulation, and failure of refractory around the superheater. Typically, this refractory will not be inside the superheater, but found in the walls near the superheater. Also, look for metal problems: erosion, corrosion, pitting, cracking, or scale on the tube surfaces, failure of construction welds, and leakage. Finally, since radiant superheaters are made of tubes, you must also check for tube thinning, soot blower problems, and deterioration in those areas where tubes enter and exit the boiler. Radiant superheaters can have many of the same problems as the water wall because both are located in the same general area. These same kinds of problems occur throughout the entire boiler, but most components also have some individual features that require inspection. As I've said, many of the problems that affect the water walls can occur throughout the boiler. With that in mind, and remembering that your inspection actually begins while the boiler is still pressurized, let's talk about problems and problem areas in the superheaters and reheaters. There are many names for superheaters based on the way they absorb heat, their location in the boiler, and their tube arrangement. Superheater names will vary from plant to plant, but we'll cover some typical ones. We've already talked about one type, the radiant superheater. Now we'll discuss some others: the platen, pendant, and horizontal superheaters. We'll take them as a group because their construction and kinds of problems are very similar. We'll include reheaters here for the same reason. Remember, superheaters and reheaters are different components, but they are built in much the same way and suffer from similar problems. So the material we'll cover applies to both. General problems that show up in superheaters and reheaters include overheating, support failure, excessive ash accumulation, and refractory failure around the superheaters. Overheating in superheaters and reheaters can be detected by warping, leaks, and tube blisters. Warping is immediately apparent when you examine the component. Superheater and reheater tubes are supposed to be in line and parallel to each other. If warping has taken place, the tubes will literally stick out like a sore thumb. Warping may also cause an additional problem. Warping alters the distance between tubes, which in turn changes the flow pattern of the gases passing through the superheater. The flow can then become channeled in such a way that erosion increases on some tubes while ash builds up and collects in other places. Check for these when you find warping. And while you're in the area, be on the alert for leaks. If you find a leak in the superheater or reheater tubes, the area around them should be inspected for blisters. Blisters are an indication of overheating. Blisters can be pretty hard to find, especially if they occur on a tube inside the superheater bundle. One way to check these hard-to-find blisters is to shine a light along the length of each tube. And if a tube is blistered, the blister will cast a shadow. It is important that you recognize warping, leaks, and tube blisters as symptoms of overheating. Understanding the primary cause of these problems will make a difference in the way you deal with each one. For example, there might be operational adjustments that can be made to correct overheating. Another general problem in superheaters is support failure. Watch for support failure when inspecting the superheaters. Total support failure is a very serious problem because it can lead to collapse of the superheaters. Pendant and platen superheaters are suspended from the top of the boiler. Each tube element is attached to headers located outside the hot gas path. The headers have their own supports. If the header supports break, you may not be able to see the break itself, but you will notice that the superheater tubes are out of position. Another thing to look for during superheater inspection is clip and tie bar failure. Clips and tie bars hold the superheater elements in proper position in the hot gas path. Failure of clips and tie bars makes it easier for tube elements to warp out of position. Some supports for the horizontal superheaters are located within the hot gas path. Usually this kind of superheater is supported from above. However, there may be tie bars to hold the superheater's bundles together. Tie bars also provide support for the lower parts of the tube elements. Since these supports are exposed to hot gases, they're more likely to fail than supports located outside the hot gas path. Regardless of the type of supports a superheater uses, all superheaters and reheaters, like all boiler components exposed to ash, are subject to excessive ash accumulations. Now, some of this ash accumulation is unavoidable. But the important points to remember here are that it is important to detect ash accumulation and that areas near the accumulation should be closely examined. The final problem common to most boiler components is refractory failure. Refractory in the superheater and reheater areas is no different from refractory elsewhere in the boiler. You should look for the same kinds of refractory failures in the superheaters and reheaters that you look for in the rest of the boiler, especially spalling and cracking. Well, we've now discussed 4 more water wall problems: clinker damage, flame and fuel impingement, trouble with burner openings, and trouble with inspection doors. We've also covered some things to look for in the superheaters and reheaters, including overheating, support failure, excessive ash accumulation, and refractory failure. Let's take a few minutes to go over the material in your texts and clear up any questions or problems you might have.